Hello everyone, welcome back to Code Enzyme. This is the 13th video of the series, Graph Algorithms for Competitive Programming. And in this video, we are going to discuss a problem on topological sort. Now, I know I said in the previous video that I will discuss, the next video will be about minimum spanning trees, but I found a very nice problem on Codeforces, which is from a very recent contest. So yeah, in this video, I'm going to discuss the approach of this problem, chart screenshot from Codeforces round 925 Div3. Now, from the title, you already know that this problem is about topological sort. So the link is in the description. Kindly go to this problem and give your honest 20 to 30 minutes on figuring out this problem on your own. And if you are still not able to do it, you can come back here and watch the video from here. And if you are able to do it, you can just move on to the next video. Yeah. Okay. And kindly give an honest attempt, because CP is not about learning concepts, it is about applying those concepts in solving the problems, right? I am assuming that you have actually paused the video and tried this problem on your own. Okay, now let's see the problem statement first. There are n people in the programming contest chat. The chat participants are ordered by activity, but each person sees himself at the top of the list. For example, there are 4 participants in the chat, 1 2 3 1 4. Then the first person will see himself first and give the relative order 2 3 4. I think 2 3 4, yeah. And the second person will see himself first and then the relative order of 3 1 4. And the third person sees himself first, so 2 1 4, like that. And similarly for the fourth person. Key people posted screenshot in the chat which shows the order of participants shown in their user shown to this user. The screenshots taken were within a short period of time, and the order of participants has not changed. Okay, the task is to determine whether there is a certain order that all screenshot corresponds to. Now, actually, this problem was made easier, and it could be solved with if there is a cycle present in a directed graph or not. But okay, if it was given that we also need to find this order, one of the possible orders, then we have to use topological sort. So a standard way to go about this problem would be topological sort. Now, okay, let's create a new page. Okay, now since we have some things like, if we see this like 1 2 3 4, we have 1 2 3 4. Okay, then we have 2 3 1 4, 2 3 1 4. Then we have 3 2 1 4. 3 2 1 4, and then we have 4 2 3 1, 4 2 3 1. And from this, like if first element will not give me anything, it is kind of useless, but these 3 numbers give me the relative order, right? 2 should come before 3, 3 should come before 4, right? And like if I have 1 2 3 4, what I can do is I can add some edges to this graph. Like I know 2 should come before 3 and 3 should come before 4 and 3 should come before 1. So okay, so we have like this. Then 1 should come before 4, so we have one more edge. Okay, then 2 should come before 1, so like this. And now 4 should come before 1. 1 should come before 4, that edge was already existing. So I think we have to maintain a set of edges because we don't want to repeat the edges, otherwise it might give you a wrong answer. Okay, then 2 2 3, so 2 2 3 was already present, 3 2 1 is already present, and then we want to do a topological sort. We want to find a topo sort of this, and if the topo sort of this graph exists, like let's say from 1, we want to find a topological sort, and if the topological sort of this whole graph exists, then we print a yes, otherwise we print a no. So that is the simple approach of this problem. I know it was an easy problem from a Div3 contest, but yeah, it is a problem of topological sort. So I just wanted to include some problems based on topological sort that you can see during the contest. So you should know that such kind of concepts actually appear in the programming contest, right? Now, if you want, you can code with me, or you can even pause this video and try to code it yourself. Okay, so first we have an integer, and okay, let me use my template. And okay, for every test case we have 2 integers n and k. So int n comma k and c in n and k, right? Yeah. Okay, now we have n and k. Then the number of chat participants, obviously. Then we want to create a graph of n plus 1 numbers, right? So I can say vector int graph of n plus 1 numbers, and for I in range, I think we had n participants. Now, now obviously we want to have vector int a of n for I. Then we will have n numbers, and now when do I even need to store this? I don't even need to store this, right? I can say, okay, let's take maybe let's take the graph input. Let's take this array input a of I. Okay. Now for we want to traverse in this whole array. Like, okay, let's traverse it once more, but from index 1, because the index 0 is useless. It doesn't give me any information, and we have to go till n minus 1 because okay, we have this. Now I want to add the graph edges, so I can say graph of a of I dot pushback a of I plus 1. So I've made a graph, but there is an issue that these edges might repeat, right? And this will just increase my memory or the space complexity, and these edges will be useless. So what I can do is I can make a set of edges instead of vector of edges. Okay, so I will convert this to an insert function. Now now I want to find my topological sort. So let's say vector int topo and vector int visited of n plus 1 comma 0. Okay, I mean, in the topological sort video, I maintained a stack also. So this visited, I will store 1 if the current edge is inside the stack, and 2 if it is completely visited. Okay, so let's make a function dfs and not a void function int dfs, and it is a lambda function. Okay, so we have this, and now I want to call my dfs of 1. Right. Okay, I mean, do I even have to do this? No, I don't even actually have to do I have to find a topological sort. So I'm simply trying to just detect if there is a cycle in my graph or not, right? So since we want to find the cycle, I can first of all I can say, let's say visited of node equals 1. All right, so this node is in my current stack, and in the end I will say visitor of node equals to true. Now since I don't want to find a topological sort, I'm not writing topo.add node or anything like that. Now I can traverse in the int x in graph of node, or you can say int child. Okay, child. Now okay, now I will go for in every child, like okay, let's just go there. So I will say dfs of child. I mean, if even here I have to say, like, if I have to check if the child was in the current stack or not. So if visited of child equals 1, so if the child was already in the current stack, then we detected a cycle. So I will have to see out no and return. Let's actually keep a bool function, because let's have a bool function. So check equals to true. So initially I am assuming that so a topological sort actually exists. Now I can say check equals to false, and if not check, and obviously if my check equals to true, then only I want to do the dfs further, or else I don't want to do it. And what visited of child, and visited of child was equals to 0 and not visited of child. So I can say it like this: we want to do the dfs of child. So using this, I have detected that if my directed graph contains a cycle or not. And from dfs of 1, now I can say, like, okay, if check, we can simply print a yes, else we can simply print a no. Okay, it has some errors. First of all, this should be till k and not till n, because I think I read the input format wrong. Now what could go wrong? And now I have to traverse, I mean, it should not be only dfs of 1. I should say for I in range 1 to n, If that node is not visited, so if not visited of I, then I should do DFS of I. So because the graph can be connected of disconnected components, right? So yeah, let's try to see if it gives us a correct answer. Yeah, it passed. And now let's try to submit this. So submit, and okay, a solution got accepted. And if you were able to understand this, kindly like this video and subscribe to the channel. I will see you guys next time. Thank you.